yesterday we did the notes that kind of laid out the relationships that we should see within the construction of these perpendicular bisectors. So if I take, it's kind of rehashing what we talked about yesterday. The perpendicular bisectors, let's write it this way, the three perpendicular bisectors of a triangle are they're going to be concurrent. They're going to lead you to the circumcenter. Okay? Remember, the circumcenter, we said that that is the center of the circumscribed circle. Okay? And just give you a quick picture of the circumscribed circle. If I have that as a triangle, oh, that's terrible. We'll say that as a triangle. The circumscribed circle, let's do it this way. It's easier to draw the circle and then the triangle. Maybe. All right. So, it sucks, right? The red circle is a circumscribed one. It's the one circle that will pass through all three vertices of the triangle. Okay? Now, that led us to three different things, and the locations essentially of the circumcenter. In an obtuse triangle, the circumcenter was where? Outside. On an acute triangle, it was where? Inside. And then on a right triangle, it was where? On the hypotenuse. Now, where at on the hypotenuse? Okay, on the midpoint of the hypotenuse. So, let's see here. Okay, on the midpoint of hypotenuse. So that is all of the information that we kind of encapsulated yesterday in yesterday's notes. Okay. We didn't do any examples yesterday, but my hope was that if you knew this stuff over here in the blue, you should have been able to work through pretty much all the homework questions in that assignment, because all of the questions somehow gave you that situation. They gave you a right triangle. I want to walk through a couple of these and then do a couple examples that are slightly different than what the homework was. So, and again, that homework is still open. So if you have not completed it, this could be of use to you when you do end up completing it. So I think question 8, 9. There we go. So if I look at this picture here, okay, the question was find the circumcenter. What kind of triangle is that? It's a right triangle. It's 100% a right triangle because that vertex is at the intersection of the x-axis and the y-axis, right? So where is the circumcenter? What's its location going to be? The midpoint of the hypotenuse. The hypotenuse is defined by the ordered pair -6, 0 and the ordered pair 0, -10. That is what's going to create that hypotenuse, right? If I find the midpoint by adding the x's and divide by 2, gives me -3. Add the y's divided by 2, -5. So now I have the circumcenter. Does that make sense? Okay. Every question they give you, except for the last one, are that way. Now, they might not have a vertex at 0, 0. Okay, but we'll talk about how we can interpret the ordered pairs that they give us and realize that they are indeed right angles. So the next question targets that. If I look at this one, I want to talk through it first, but then we'll draw a picture. If I look at this point A, let's color different. If I look at A and C, what is the same in regards to those 2 points? The x value. So how do those 2 points align with one another in the coordinate plane? They don't. The only way they would touch is if they're the same point. Okay, so they're on the same vertical line, right? One is on top of the other one, right? So if we were to draw a picture of this, point A would be at 8, 7, maybe right there, right? Point B, point C, the other one we highlighted, would be at 8, negative 5. Well, don't I have to go over, to get to 8, negative 5, don't I have to go over the same 8 units that I did to get to A? But now I go down 5. Okay, so those 2 points are vertically aligned with one another. That's something to think about. Now, as I look at the other point, which is this one here, how does that one relate to that one? Yeah, they have the same y value, so they're going to be horizontally aligned with one another. So I go over negative 7 and down negative 5. It puts point B right there, negative 7, negative 5. So this segment here is what kind of segment? If these y values are the same, what's the word we use for that? Horizontal, right? Okay, horizontal, thank you. What is this one? Vertical. Any 2 horizontal and vertical lines are always what to one another? Perpendicular. So is this segment here of importance to us? Yeah, because that's the what? The hypotenuse. And the circumcenter is located where on that thing? The midpoint. So I take that ordered pair and that one, add the x's, it's going to give me 1, divide by 2. Add the y's, it'll give me 2, divide by 2. There's my ordered pair for the circumcenter, right? Okay. Now, you keep going through the other examples, and they're all that way. Okay. I want to do one that is still a right angle, but the points might not orientate themselves real well that way. Let's say I gave you, let's see here. Let's go to GeoGebra and do this. If I look at that right there, okay, those order pairs, so in the problem they give you 2, 2, 14, 2, and 8, 8. If I look at those, is there a right angle? It's not as easy to see as it was in the last one. The last one is because we were able to determine that we had vertical lines intersecting horizontal ones, right? And whenever a vertical line and horizontal, by definition, intersect, you get perpendicular lines. Would you agree that's probably not a right angle? Probably not, right? Okay. If there's a right angle, it's probably this one. What can I determine about that segment right there, and then that segment right there that we can compare to see if indeed we do have a right angle right there? If they're perpendicular. Well, what algebra tells us that 2 lines are perpendicular? They're slopes. Okay, there's a relationship between the slopes. So let's find the slope of the blue line. Slope of the blue line would be that y value minus that y value, right? So 8 minus 2 gives me 6. Over that y value, that x value minus that x value, right? What's that give me? 6. What's 6 over 6? 1. Let's do the same thing with the red one then. Okay? That y value minus that y value, right? What's that give you? 6. And now that x value minus that x value, what's that give you? Negative 6. What's that give me? Negative 1. What was the relationship that was necessary for lines to be perpendicular? Opposite reciprocals. Opposite sign reciprocals. Are those 2 things opposite sign reciprocals? They are. Okay, now, not as easy to see, but 1 over 1 is the reciprocal of 1 over 1, right? Another way of talking about it is, didn't we say that the product of the 2 slopes, product of the blue slope, product of the, with the red slope, that product to be perpendicular had to be negative 1? Does 1 times negative 1 give me negative 1? So it is, they are perpendicular, right? So that is indeed 100% a right angle. So if that's a right angle, where does the circumcenter show up? The midpoint of the hypotenuse, right? Add your x's divided by 2. 8. Add your y's divided by 2. 2. 8, 2 is going to be that circumcenter. And if we put the perpendicular bisectors in there, does it go through 8, 2? Yeah. Okay. So that's what we're looking for on those types of questions. All right. When they give you 3 ordered pairs, see if they have it, if they give you a right triangle, because that's the easiest case, simplest scenario that's going to allow you to work through the fastest. Okay. Now think about this. How many different types of triangles are there? Are right triangles the only triangles we ever deal with? No. We have acute ones. We have obtuse ones, right? If we have acute ones or obtuse ones, the circumcenter is not as easily found, but it is still something we can find. All right, so that's what I want to do right now. I want to walk through a situation where we do not have a right triangle. My hopes are that you realize 2 things here. First, when they ask you to find a circumcenter, I want to see if they're right triangle first. Because if it is, I would hate to go through all the work we're about to do to find out that I could have came across the same exact answer using the midpoint of the hypotenuse. Does that make sense? Because the work we're about to do is going to be very strenuous. Okay, it's going to be pretty difficult. Okay. The other thing I hope you realize is that everything that we're going to do here is now taking your Algebra 1 skills, the things that you spent months and months and months on last year developing, and now we're going to actually apply it and see why we learned that algebra from last year. Okay. We had a discussion last period with some people. You think, when we're done, how hard was that algebra, and how hard was it to generate that information? And then ask yourself, okay, how did I get through Algebra 1? Did I get through it with dedication, hard work, and effort, or did I get through it because I had a buddy that gave me all the answers? Okay? That buddy that gave you all the answers is probably doing pretty well right now in this class, but you're probably going to struggle with this stuff because you didn't take the time then to really understand the importance of that algebra. Okay? If that's the case, if you're that person, think about the situation you're in now and how that's going to compound next year if you continue to use that buddy to do the work for you. Does that make sense? Okay? Because guess what we use next year in Algebra 2? Algebra 1 and geometry. When you get to pre-calculus, guess what we use? Algebra 1, geometry. Algebra 2. Okay? So every year, the courses incorporate previous courses. That's why they're called prerequisites. Okay? That's why we have to sign that paper for you at the end of the current school year. So like beginning of January, end of January, they'll give you that paper for you to schedule, right? And we got to sign that, okay? Because I'm saying, when I sign that, I'm saying, yeah, you've got the skills to be successful in Algebra 2, okay? Now, I want to deal with, you're going to want to start on a fresh piece of paper when you're doing this, okay? And you're going to want to give yourself a little bit of room with your picture. So make your picture, I'd say maybe a quarter of your page, okay? Because you're probably going to draw on top of your picture, labeling on top of your picture, that kind of stuff. But we're going to try to use some different points than what the last class has used. Fabulous. How's yours? Good. All right, so I was going to start with that triangle there. Triangle ABC with those points of 410, 2, 2, and 8, 4. So give you a minute to write that down, and then I am going to do a little bit of work real quick. All right. So here's the thing. Here's what we're going to do. You guys remember last year, if I were to give you two lines that intersected, last year you would go through the system of equation work. You would have been provided the equations or formulas for those lines, right? And then you took those two equations and you either used a substitution technique or elimination technique to find the x and y in which those two things cross, right? We're going to do that exact same thing right here. However, the information that I start you with is no longer the two equations. The information I start you with is that. Okay? So we have to generate the equations. We have to make the equations before we can set them equal to each other to solve for x and y. Does that make sense to everybody? So we're going to use several different concepts that you practiced last year in kind of conglomeration of or in hand with the geometry that we talked about yesterday. Okay? So we want to find the circumcenter. That's the goal here. We need to know, or we understand that the circumcenter is the intersection of those three perpendicular bisectors. We talked yesterday that we really only need any two of them, right? We don't need to deal with all three of them. So this process, maybe I don't deal with that third one, and I'll just deal with these first two, okay? Now, I want to just deal with one at a time. So I'm just going to kind of highlight these and deal with them one at a time. We need to come up with the equation of that perpendicular bisector, okay? The equation of that perpendicular bisector. Well, if I'm going to write an equation for any line, there are two things that you need. Okay, so this is the point-slope form, and the things that you fill in there are a point and the slope, right? That's why it's called point-slope form. They're telling you what parts you need to create that equation. So if I'm going to write an equation for that black line, I need a point on that black line, and I need the slope of that black line. Neither of those two things am I really confident in just by looking at it. Does that make sense? So we're going to find those things kind of indirectly. Find a point on that black line. We have to understand, how does that black line relate to that blue segment? That black line is the what of the blue segment? Bisector. Better yet, it's the perpendicular bisector. Okay? Now you said midpoint, right? Okay? The word bisector tells us we're passing through a midpoint. So the black line goes through the blue line's midpoint, right? So would you agree that the blue segment's midpoint is on my black line? Do you have the ability to find the midpoint of that blue segment? Okay, the midpoint of that blue segment would be take that value, add together, divided by 2, right? So that would be, what, 6 divided by 2 is 3? Okay, and then you do something to the y value. So 10 plus 2 divided by 2 would be 6. So we know that 3/6 shows up on our perpendicular bisector, right? So when I come over here to this formula, that 3/6 is my x1 and my y1. Everybody kind of see that progression? All right, that is the only point that I'm extremely confident on being on that line. Okay, you don't ever, when you're doing this, you don't ever want to just look at the line and say, it looks like 12, 3.8 is on there. Okay, that's a very, very bad approach. Okay, if we can use an approach that provides me an exact point, then we're going to do that, and that's through the use of the definition here. Okay. Now I need the what of that line to create the equation. I need the slope. Okay. How many points on any line do you need to find slope? 2. How many points do we have on that black line? If I were to just look at the black line, look at that, just the black line, how many points are highlighted on it? Just one, right? So with that black line, you do not have enough information to complete the slope formula. How many points are on that blue line, though? You know 2 points on that blue line. And you know the relationship between the blue line and the black line, don't you? They're perpendicular, so their slopes are opposite sine reciprocals. So if I can find the slope of the blue line, okay? So the slope of AC. The slope of AC is going to be y2 minus y1. So that gives me what, 8? Over x2 minus x1. Gives me 2, right? So the slope of that blue line is 4. Is everybody okay with that? Slope of the blue line is 4. If we write it as a fraction, it's 4 over 1, right? What's the reciprocal of that? The opposite sine reciprocal is negative 1/4, right? Okay? So that's what we're looking for. So the slope of this black line, and if I just ask GeoGebra to do this for me, you're going to see 0.25 show up. Negative 0.25. See that? That's negative 1/4, right? So we've just done the algebra to show that. The slope that I'm going to plug in right here is negative 1/4. My biggest problem that I have, and it's because I'm kind of restricted to the size of the smart board and I've got to draw things so that everybody in the front and back can see things, is that my work is kind of all over the place, okay? I try to, on my own, and I do that same thing on notebook paper and all that kind of stuff, I try to make sure that I'm detailed in my labeling and that kind of stuff, okay? So I'm going to, when we're done, just remind myself that this is the equation for that perpendicular bisector. Somehow I'll write that out, okay? But this isn't slope or point slope form still. We want to solve for y. Okay, that's going to be the easiest thing that for us when we get to the end of this problem, if this equation is solved for y. So this is where the Algebra 1 review that I gave you on Tuesday kind of comes into play. We distribute that. So I'll have y minus 6 is equal to negative 1/4 x plus 3/4, right? Is everybody okay with that? Now, how do I solve for y? What do I need to do? Add 6. So we get negative 1/4 x plus 3/4 plus 6, right? Now, a lot of times maybe people don't write the plus 3/4 plus 6 like I did, which is fine. But are those like terms? So are they going to merge together? How do I merge them? What do I need to add fractions? Common denominator. So what's that denominator going to be here? 4. So what's that 6 turn into then? 24. That's still 6, right? 24 over 4 is still 6, right? So now when I add those together, does that give me y equals negative 1/4 x plus 27/4? Okay. That is the equation of AC's perpendicular bisector. Okay, so that's kind of what I mean by I'm terrible at organizing my work, okay, and I'm a lot of times all over the place. But if I label things and I know what that is later on when I need to use that, I can easily find it, right? So that is about a third of the problem. Okay, so we got to do that again. Because so when we get 4 over 1, that is the slope of that line there, right? Slope of the blue line. If we know this black line is perpendicular to it, the slope of two lines that are perpendicular, one of them, if it's 4, the other one has to be opposite sine reciprocal of 4. So if this is, so the blue line slope is 4 over 1, then to find the reciprocal, we take that and put it in the numerator, take that and put it in the denominator, and then we put a negative on it. And that will 100% of the time be the slope of that line perpendicular. Does that make sense? And that's just something we always have to, if we're dealing with things that are perpendicular, we have to recognize that that property for perpendicular lines and their slopes. So I said that is 1/3 of the problem, because what happens is to come up with that circumcenter, the place of intersection for these two lines, we need both lines, right? We need equations for both lines. So we're going to do this whole thing again, but with different ordered pairs. Okay, so I'm going to just kind of clean this up a little bit. Okay, obviously your picture is probably going to get kind of messy, right? Because you can't just erase the lines and start all over. But I'm now going to look at that perpendicular bisector or that one. It doesn't matter. I'm going to look at that one. Okay. So we're looking at, that is the perpendicular bisector of that orange segment, right? Okay. If I'm trying to find the equation of that perpendicular bisector, again, I'm going to start with this, and I'm going to try to fill in the three missing things there, x1, y1, and m. What is a point that you know for sure is on that black line? The midpoint of the orange line, right? Or the orange segment. So I find that midpoint by adding my x's, divide by 2. Gives me 5. Add my y's, gives me 6, divide by 2, gives me 3, right? So that point right there is your y1 and your x1. Now we have to find the slope of that black line. Well, I need 2 points to find the slope, right? I don't have 2 points on that black line, right? So this is called finding the slope indirectly. Find the slope of another line and understanding how that other line interacts with the line that we're trying to find the slope for. Okay, so that other line is this one. We can find that one's slope, right? The slope of CB should be 4 minus 2. So 4 minus 2, and then 8 minus 2, right? 4 minus 2 is 2. 8 minus 2 is 6. So I get 1/3. Everybody okay with that? The slope of this line right here is 1/3. So the slope of anything that is perpendicular to it, any line that's perpendicular to this one is going to have a slope of what? -3. So this slope right here that I'm looking for has to be -3. It's the opposite signed reciprocal of that number right there. Flip that number, it comes 3 over 1. Negate it, it becomes -3. Okay. So now we've got that black equation up there. We can go ahead and distribute. So it gives me y minus 3 is equal to -3x plus 15. And now I'll add 3 to both sides, so we get -3x plus 18. That one's a little bit nicer because there's no fraction work there, right? Okay, and that's just, it's kind of unavoidable with these. A lot of times you're going to get answers that are ugly. You're going to get equations that have fractions in them. That's what I've told you in the past. We want to get good at fractions. We want to have that 5th grade skill. Okay? Yes, Trey?
What are we trying to find at the end of this?
Okay, so we're trying to find the location of the circumcenter. The location of the circumcenter. And the location of the circumcenter is found by the intersection of those two lines. Does that make sense?
Yeah.
Right now, just kind of clean things up for you. We've got y equals -3x plus 18 as the perpendicular bisector of BC. Okay, so that's the equation of that. So if I just eliminate all this stuff, all this picture stuff, get rid of that segment there. Maybe even I hide that, hide that, hide that. Okay? We have these two lines, right? This line right there is 3x plus 18, and this line right here is negative 1/4 x plus 27/4, right? So this is now going back to Algebra 1. Okay, at the beginning of the question, I said, remember, if I gave you that picture in Algebra 1, you were able to solve for where they intersect, right? You'll find the x and y that they intersect because you were provided in Algebra 1 on worksheets or Math Excel or whatever. They gave you those two equations. Well, we just found those two equations. We did that work. And now we can go through and say, okay, let's do the other aspect of algebra. If these two lines are created through these equations, and they cross right there at an x comma y, it means that the y value on that line right there, so that y value, does that make sense? Yeah. That y value is on that line, and this y value right there is that one. Does that make sense? Well, at that spot, aren't those two y values the same? Yeah. So if those y values are the same, then the expressions that generate those y values have to be the same. So we set the negative 3x plus 18 equal to the negative 1/4 x plus 27/4. That's the system. That's substitution in regards to solving a system of equations. Okay, you solve one of your equations or both of your equations for the same variable, and then replace them. Okay, fractions, right? What do I need to multiply everything by to rid this equation of fractions? 4. Okay, so I'll multiply negative 3 by 4, so it gives me negative 12x. I'll multiply 18 by 4. What's 18 times 4? What's 18 times 2?
That's how I did it in my head. 72.
Okay, so 18 times 4 is 72, minus then negative 1x, plus then 27, right? Over here was this going to 1x and plus 27 is the purpose of multiplying by 4. Can I add 12x to both sides? I mean, if you wanted to do negative 4, that's fine. Just all your signs would be in the opposite of what I have up there. So I add 12x to both sides. I'll subtract 27 from both sides. So 72 minus 27. So turn in 5. What is that? 45? And now x ends up being 45 over 11. Leave it as 45 over 11. Leave them as fractions unless they reduce to something real nice, like a whole number or an integer. Leave them as the improper fraction. So the x value right here, the x value is 45/11. Do these two equations tell me what y is if I know an x value? Which one of those you want to plug into? Yeah, because there's no fractions there, right? Now, you're not going to be able to avoid fractions because you're substituting a fraction in, but the fractions that you get are going to be simpler here than what they would be here. So I'm going to have negative 3 times 45 over 11 plus then 18. So when I multiply negative 3 times 45/11, negative 3 times 45. Okay, that's 135, isn't it? And it's negative 135 over 11. Okay, now 18 times 11, because I need a common denominator of 11 here, right, with this 18. So this top's going to be 18 times 11. What's 10 times 18? 180. Okay. What's one more 18 on that? 198. So 18 times 11 is 198. Okay. What's 198 minus 135? What's 200 minus? Okay, so 200 minus 135 would be 65, right? And then we had 2 too many, so you're going to go 63. Okay, so 63 over 11 is that y value. Okay. Now, my hopes are, guys, that you realize, and even if you're grabbing your calculators to do that stuff, sometimes your calculators might complicate things because they might not give you that decimal or that improper fraction back. They might give it to you as a decimal. Well, if I take 63 divided by 11, I'm going to venture to say it's really not a nice decimal. and I got to cut it off, right? And if I round that value, I no longer am at the intersection of those two lines. Does that make sense? If I would have rounded any of the values throughout this entire problem, 27/4 or anything like that, 27/4 is going to terminate. But if I would have rounded any single fraction in there, I am now no longer dealing with those two lines and the intersection of those two lines. I'll be slightly off. I'll be in the ballpark, but I'll be slightly off. Okay? Now, just the way I would check myself here, since I am using GeoGebra, type in 45/11, comma 63/11, and see if that point shows up at the intersection, right? So, obviously it's a lot of work, a lot of information, but what does that point do for us? Okay, if I were to find that distance right there, okay, and use that as a radius of my circle centered at H, that circle passes through all three vertices of the triangle, right? That's called the circumscribed circle. Okay? Because H is on the inside of that triangle, I automatically know that triangle would have been acute, and I didn't even look at the angle measurements, right? If that H would have been on the triangle, it would have been a right triangle, correct? And if it's on the outside, it's obtuse. A lot of work, agree? Okay, so, but none of that work is outside your abilities, okay? None of that work is new to you. It should be something that we covered last year in Algebra 1. And it's something we can keep working with. Here's my, I'm not going to give you my phone number. Here's my suggestion to you, okay? Or maybe some insight here that I'm going to provide you for what we're going to see and encounter in the rest of this chapter. I don't want you to get scared, but I want you to understand that this chapter is pretty difficult, okay? Because the next thing we're going to do in this chapter is we're going to look at that segment and that segment. Those are different than perpendicular bisectors, right? Okay, you're not writing this stuff down right now or anything, but those are called medians. They intersect, don't they? Well, they're lines. They're portions of lines. So there's an equation to both those black segments. Guess what we're going to do? We're going to find the equation of those two things and find out where they intersect, doing what we just did. Okay? Then we'll do the same thing with another grouping of lines called altitudes. Okay? So this process that we just went through in this type of problem is going to replay itself again with those segments. And it's going to replay itself again with altitudes. Okay? So we'll keep doing this. All right, now our x sub 1, y sub 1 might come from different places, different points, and our m might come from different relationships. But once we have those, the algebra is the same after that. Okay? And the way we find those x1s, y1s, and m's are going to be based off the definition of those segments. Does that make sense? Continue to work with this stuff. We've got that assignment available right now, due on Monday. What I have done